Hello friends, learning made simple. You are welcome to my scholars and this is Sami. In this video we shall learn about class 10th maths trigonometric identities NCERT exercise 8.4 question number 5 part 4th, 5th and 6th. Let us see. This is part 4th. If you are new on our channel, please subscribe the channel. So part 4th is 1 plus sec A upon sec A is equal to sine square A upon 1 minus cos square A. So for this we shall take LHS and prove LHS is equal to RHS, taking LHS left hand side, that is 1 plus sec A upon sec A. We know that sec A is equal to 1 upon cos A. Writing 1 upon cos A in place of sec A, so that will become 1 plus 1 upon cos A, and in denominator 1 upon cos A instead of this sec A. Taking LCM of numerator, so that will become in denominator cos A plus 1 and whole upon 1 upon cos A. In our next step, that we shall take cos A plus 1 upon cos A and divide it by this 1 upon cos A, right, like this. So we do the reciprocal of 1 upon cos A and place the sign of multiplication instead of this division. So that is cos A plus 1 upon cos A into reciprocal of 1 upon cos A is cos A upon 1. We can reduce this cos A with this cos A reduced and get cos A plus 1 only. We can write this cos A plus 1 as 1 plus cos A, and for this 1 plus cos A multiplied with numerator and denominator with 1 minus cos A. So 1 plus cos A within bracket into 1 minus cos A within bracket upon 1 minus cos A. Right now, that is equal to, this will become 1 minus cos square A. Numerator will become 1 minus cos square A and denominator will become 1 minus cos A. We have an identity 1 minus cos square A is equal to sine square A. Replacing this 1 minus cos square A with sine square A. So that will become sine square A upon 1 minus cos A, which is RHS, hence proved. Part 5th, that is cos A minus sine A plus 1 upon cos A plus sine A minus 1 is equal to cosec A plus cot A. Again taking LHS. LHS is this part, so taking LHS. LHS is cos A minus sine A plus 1 upon cos A plus sine A minus 1. We shall rationalize the denominator by multiplying numerator and denominator with cos A plus sine A plus 1. So doing cos A minus sine A plus 1, taking within bracket and in another bracket cos A plus sine A plus 1, multiplying with this numerator and denominator. In denominator there is cos A plus sin A minus 1. Cos A plus sin A is taken in one bracket and then minus 1 is taken in a square bracket, and thereafter other square bracket cos A plus sin A is taken in parenthesis plus 1. So this has become A and this has become A. This has become B, 1, 1. Using the formula in denominator, A plus B, this is A and minus 1, A minus B, A plus B is equal to A square minus B square. And in numerator, multiplying this whole with this whole with this, and this whole with this. So multiplying with cos A plus sin A plus 1. So that is cos into cos square A plus cos A into sin A, cos A into sin A plus cos A into 1 is equal to cos A. Similarly, multiplying this whole with sin A, so minus sin A cos A, it will become minus sin A cos A, minus sin into plus sin A will become sin square A minus sin square A, minus sin A plus 1 is equal to minus sin A. Now multiplying this whole with 1 into cos A is cos A, 1 into sin A is sin A, plus 1 into 1 is 1. And in denominator, as I told you, this is A and this is B, this is A and this is B. So using this formula, A plus B into A minus B is equal to A square minus B square, where A is cos A plus sin A, B is 1. That will become in denominator cos A plus sin A whole square minus 1 whole square. We can reduce this cos A sin A with this minus sin A cos A, since both are same with negative sign, and this sin A can be reduced with sin A. So in denominator we have, after reduction, a next step, that is cos square A, that is cos square A minus sin square A plus cos A, and this cos A, 2 cos A plus 1. And in denominator, that is sin square A plus cos square A plus 2 sin A cos A minus 1. So this 1 is reduced with this 1, and in place of sin square A plus cos square A we shall place 1. So the whole, it has become cos square A minus sin square A plus 2 cos A plus 1, and in denominator sin square A plus cos square A, breaking the whole square, making the whole square of this cos A plus sin, which is using A plus B whole square, A square plus 2AB plus B square. So that is A square plus B square plus 2AB minus 1 is as it is. Thereafter, the next step, it will become cos A plus 2 cos A, and taking 1 minus sin square A within bracket. We have 1 minus sin square A is equal to cos square A, and in denominator we cancel this one with this one, 2 sin A cos A is remain. So in numerator cos square A plus 2 cos A, and turn that into cos square A using this formula. Now 2 cos square A plus cos square A, 2 cos square A, 2 cos A, in denominator 2 sin A cos A. Taking 2 common, in numerator it will be only cos square A plus cos A, and in denominator 2 sin A cos A. 2 is reduced with 2. We have got, after reduction, cos square A plus cos A upon sin A plus cos A. Now, we distribute the sin A into cos A. Here it is into cos square A upon sin A cos A, and plus cos A upon sin A cos A. This way. So cos square A is cancelled with this cos A, and we have got cos A in numerator, and in denominator sin A, cos A upon sin A. Here cos A is reduced with this cos A. We have got 1 upon sin A, so 1 upon sin A. We know that cos A upon sin A is equal to cot A. This is equal to cot A, and this is equal to cosec A. So writing in place of this cot A and in place of this cosec A, cot A plus cosec A. Next step is this. We can interchange cos A writing first and cot A after that. So cosec A plus cot A, which is RHS, hence proved. Part 6th. Square root 1 plus sin A upon 1 minus sin A is equal to sec A plus tan A. Solution. Taking LHS. LHS is square root 1 plus sin A upon 1 minus sin A. Rationalizing the denominator. In such cases, we always rationalize the denominator to remove this square. So doing so. So that will become is equal to 1 plus sin A in numerator, multiplied it with 1 plus sin A. In denominator, there is 1 minus sin A. It is also multiplied with 1 plus sin A. We have A plus B into A minus B is equal to A square minus B square. It is A and it is B. A and B. So in numerator, it became 1 plus sin A. Since 1 plus sin A into 1 plus sin A is equal to 1 plus sin A whole square. And in denominator, we have got A square minus B square. So 1 minus sin square A. Next step. For 1 minus sin square A, we can write cos square A. Writing cos square A for 1 minus sin square A. So within square root 1 plus sin A whole square within bracket upon cos square A. Removing the square root, since there is a square, there is also a square. So while we remove the square root, these square will be removed. So 1 plus sin A upon cos A. Now distributing this cos A and 1 plus sin A. So 1 upon cos A plus sin A upon cos A. 1 upon cos A is equal to sec A. Sin A upon cos A is equal to tan A, which is RHS. Hence proved. Please like and subscribe our channel. Thank you for watching my scholars.